All right. So next one is called signal boosting. Hope you guys are awake with the previous excellent talk. So hope for this one will also keep you awake. So my name is Xiangpeng Zhao. I work in Facebook mobile performance, and here let's talk about how to catch more regressions before they hit prod. Actually, let me stand here so I'm not blocking that screen. So we know that app health signals are typically weak before prod. By signals, I typically mean like performance metrics, reliability metrics. And by weak, I look at these error bars. I'm not sure if you have seen similar charts in your company, but it's here in Facebook. Like if you look at the alpha chart, it's like, oh, huge error bar. I don't trust that data. Look at beta, looks a little, oops, sorry. Beta data looks a little better, but still lots of noise. But when things get to prod, oh, you have billions of users using your product. You can measure things pretty well. So prod data is pretty good, but that means no one is trusting the alpha and beta data. That's awesome. So why are signals weak before prod? Well, let's look at the systems we have before prod. We have the mobile lab, at the CI, as a diff time, you can try to capture if there's this code change causing a problem. But in the lab system, we have fixed test users, like typically just this test user has one friend, sends one message. It's not kind of realistic, and it has kind of fixed behavior, like tap button A, tap button B, that's it. So it's kind of has low coverage by design. And also, if we look at alpha, alpha is typically just the employees, so it has a very small number of users, and employees typically they're not the typical users, they have a very special behavior, like we're all US people using high-end devices, etc. And then if you look at the beta data, well, in beta we definitely have more users, so the data quality is a little higher. But then there's a population bias. Typically beta users tend to be like, they have better networks, they have better phones, so the numbers you get in beta is not something you can directly use to predict prod. And also in iOS, well, there's something we're still trying to work with Apple, like can we get more beta users in iOS? So what's the proposal here? It's like, can we try to generate some realistic test users? Like they're not real users, but good test users. So here's a project called Signal Boosting, started like recently. The idea that, so if we can address these issues, like if we can cover various real user behaviors in the test users, and if we can create kind of realistic text users with, like they don't have only one friend, send one message, but like behave like a real user with real, more realistic data. And then we just try to keep running the system for days as if it's like being used by real users. And then we can hope to like detect regressions, as if we are detecting things in production. And we can try to debug regressions with the profilers or tracing tools that is supported in production. And also, hopefully we can also do A/B testing analysis in production. So let's look at these issues one by one. So first is that how can we cover various user behaviors? I mean, in the Facebook app, there's thousands of buttons you can click. There's thousands of links you can click. You already see that. Never mind. But like, how can we do better testing to cover all the behaviors? Like, monkey testing. Well, monkeys are not smart, right? So here's the idea, like Sapiens, which are supposed to be smarter than monkeys. So Sapiens is a tool developed by Facebook. It's an open source tool, so you can download them freely. Wait, I don't know what I did, but it keeps moving. Never mind. So this tool is kind of automatic AI kind of exploration tool. I talked with some Google friends here at lunch. They say it's kind of called a crawler in their terminology. So basically, it tries to explore the app by automatically tapping the buttons, send a message, like type some text, scroll up and down, swipe and up and down, back and forth. So I kind of call it a iRobot Roombas, which kind of explore the room automatically. It's not like you have to write a test script saying do this, do that. It's kind of explore the app by itself. So when it runs, it's like this. It does a lot of interesting activities. It's like, it's called Sapiens for a reason. So let's say Sapiens can solve the first problem of getting good coverage of functionality. There's a second aspect that even if it can tap all the buttons, it has to tap the button if you have enough content to tap. Like if you have a test user of only one friend that sends only one message, you're like only capturing the behavior of this special case. And a typical real user, like they may have n messages sent and received, and they may send stickers, images. That's like you have to do these things in your test user to set up your test user so that you can capture these. So, but there are so many users in the world, like 2 billion users in Facebook, but how can we get them? Well, one proposal here is that let's try to use machine learning. Let's just try to pick some representative data from all the users, and then we replicate them so that like we have more realistic alpha and beta test users. So this is actually a pretty huge topic that we're just starting, because good test users means like good. This can be used in multiple places, not only performance tests. So here's an example showing like how we are like looking at the test user clusters from the machine learning. So this is actually a real data. Like we see from the new version and the old version, we compare the performance. Yes, performance improving the new version 2 to 8, and we try to check. Okay, can we break it down? So we check the different user clusters. We see that if you look at the cluster with one message, there's almost no change, the red line. And when we look at the cluster with n messages, actually there's an actual improvement we see. So this suggests that first, if your test user setup only has one message sent, you'll never catch real changes in production. And second, the hope is that you don't have to create 2 billion test users. You just try to get some clusters instead of all users to get a decent coverage of the real user behavior. All right, so that's the 2 parts to solve the problem in the alpha. And the key you see is that we use Sapiens, which is kind of the automatic robot. But there's a problem here. So we were talking about performance, but how? Because in performance, let's say this robot is kind of stupid. It keeps tapping the button 100 times or 2 times. It's like a real user may only tap it 1 time or 2 times. It's okay because performance, like it keep tapping it, it's the same number we expect. But for reliability or crash rate, it's a different problem. Like if you use this robot and which kind of explores your whole app, it may discover certain crashes, but the crashes may be a kind of a edge case crash. So it's probably hidden somewhere. It tries somehow this robot is able to find a crash in a very edge case. But does that mean it's a real problem in production? Well, it's kind of hard to say because it's not always triggered. So in this case, this kind of alpha time testing will not apply. And we're thinking like, okay, in this case, how about we use beta data in a more efficient way? So when we look at beta data, we are mostly talking about Android beta where we have more control and more data. And as we discussed earlier, one major issue is that we have a population shift issue. So we kind of have to build a simple model to adjust for the population shift. Let's take a very simple example. Let's say in your production, you have 50% users using, you have 50% users using high-end devices and 50% users using low-end devices. But in your beta data, it's not a 50-50, but maybe 80-20. So 80% are using high-end and 20% using low-end. So what's a very simple way to adjust the data? Well, let's say the metric value is just basically a weighted average of each subpopulation. In this case, it's like the high end and low end. So let's say the actual metric value is like 50% of the weight on the high end and 50% of the weight on the low end. And what you know is that in your beta data, it's like you observe the metric value for both the low end group and the high end group. And then you just try to apply the production weight, which is 50-50. So this kind of gets you a weighted average of an adjusted value that's closer to reality. But this problem actually is very kind of naive. It doesn't consider the fact, for example, the beta users are actually really different. Like they may, even if they are using the same device, maybe the beta users tend to use certain feature more often, so meaning more crashes because they're just like to use a feature more often. Also, I'm simplifying the problem just by providing like, we only split the population by high end and low end. Actually, as the previous LinkedIn talked about, like there are so many possible features. If we look at the overall spectrum of users, there's so many possible dimensions like country, network, etc. So, and once you split your data into very small subgroups, well, then you have the curse of low cardinality. Like there isn't too much data. Let's say you group by your data by first device type and then by country and then by network type. Then each grid, that's what we call it, has pretty limited data. So what's the idea here? Again, let's try to do some machine learning. So we want to predict the production value for each subpopulation we care about. So it's kind of the steps are like 3 steps here. So first, we partition the population into the subgroups in kind of a machine learning way. Like we talked earlier, like if you have 200 features, it's too much. We're gonna reduce the feature set to a very limited list. So actually, for this example, we're picking RAM size, country, and OS version as the population features. And then we try to train a model based on historical data because let's say you have this country which is very small and you don't really trust that data because maybe there's more fluctuations or just because there are less data you can leverage. So you kind of train the model, like which is a function f here, based on the subpopulation features and based on the historical values. Basically, we're trying to say, if you were a user in this subpopulation group and you have a beta metric of value x, what will be the production value you're gonna expect as your y number? And then we just apply the prediction based on the trainings. And actually, I didn't mention, we are actually also using the XGBoost model. So we're thinking about the same thing, kind of. And then we can finally aggregate the data. So keep in mind that when we do the prediction, we're doing prediction per subpopulation. So it's like one cell or one grid. And then you have to apply the same weighted average to combine those together using the production weight or percent. So yeah, that's basically it. There are a few more interesting details. Some I covered already, like we try to avoid overfit by like feature reduction. And we also try to model the trustworthy with historical values. Again, similar to the linking case. And we have another interesting idea, like we do 2 rounds of training similar to voice recognition. We kind of first train a background model, like it's kind of generic voice recognition, and then we try to apply the latest data to build a like personalized model. Please talk to me for details. It's kind of, this project has definitely lots of details similar to any machine learning project. So I won't cover everything here, but please talk to me after this talk. All right, thank you. So let's signal boost.
Thanks for the talk. Trying to understand these beta to prod prediction. Many cases when we have regression or some change in production, we're actually trying to slice the data and understand which slice actually caused the difference. In that sense, we are trying to do the reverse of beta to prod, we're actually trying to slice prod to look at each slice. So is that prediction really necessary, and why do you actually need to predict what it looks like in prod? Don't you just need the data that you have and it's already a perfect slice already?
So in production, yes. So first we did definitely do the slicing in production. So the question here we want to achieve is that before this thing goes to production, we already see the beta data. Can you say, should I take an action now? Like the typical case that we tell the production team, hey, look at our beta data. Things have regressed a lot. They're telling me that, no, I don't trust your beta data. I will wait until 3 days in production where a lot of users are already affected by the regression. And then they say, okay, I believe your data. So the hope is that we can move the prediction to earlier stage in the development so production is not affected.
Sorry, a quick follow-up. Now I understand more. So what's the result look like, if you could share?
So this is kind of a work in progress. I really couldn't share too much result, but we proved that it's better than naive ideas like the previous models.